Hi, good morning. This is Ajit, and here I'm going to show the deployment of SUSE Enterprise Storage. And for this demonstration, I'm using the set of machines salt.example.com, monitor 01, monitor 02, data1, data02. Yeah. So that is what my first machine is, Salt one. And the purpose of this Salt machine or this machine is basically to control the deployment section of the storage. So you can think of it like it's a management machine from where we'll push the deployment, from where I will control the deployment, right? And other three machines are, yeah, good. Second, yes, everything working good. Three, yeah, all right. And for data one also, just to check the connectivity, look good, great. And for data 2, yeah, all good, right? For this SUSE Enterprise Storage 6, you need a subscription. Of course, extension you need it, right? So for extension you need a subscription, right? So if you're already having a empty server, then it's good. If you don't have, then you need account under in SCC, which is of course depend on I have my account under in SCC, and I have registered myself under in a correct extension. I can check it out. Yes, two space registration, and so this is a paid extension. So you need account under in SCC so that you can purchase this extension. So I'm going to show you that because I done this part already, right? I registered my machine under in the correct account in correct extension. So you can see if you want to re-register, I don't want to re-register because I already registered. Click on extension. So under in this section you can see that I have taken SUSE Enterprise 6 checked already. In case you want to change something, you can see SUSE Enterprise Storage 6, right? If I check this CASP one, I need to have this subscription. So when I click next, it will definitely ask me for the correct key for this subscription. So yes, subscription extension is already checked, right? And I did the same process in all other 5 machines, right? So yes, one thing is done, which is SCC one. Let's write it here so that yeah, that is done already. Yes, I configure my DNS server in my Salt machine. I install my bind package here. I configure my DNS file, main configuration file. This is the one, name.com. You can see if you go down. This is the directory where I will keep my uh, uh, data resource file under in this location. So that's the default directory. So okay. Yeah, right here you can see this is what my IP address, which will listen the DNS query. The port number is 53. That is one setting. Second is it's more like a ACL thing. So I'm going to allow to my network to talk to my DNS server. So I put this range here. Uh, and little down, yeah, here I mentioned my domain name, DNS domain name, which is example.com, and working as a master. And my resource file will be there under in this location, and this is a reverse lookup zone, type is master, and the location zone file is here. So let's save it. Let's go to the location varlib, then named, and then you have, I made this folder actually, which is master, right? And I have this file here, example.com, and I put my salt with the IP monitor 01, 02, 03, data 102, and same for this reverse lookup zone file. So everything is look good. It's working. I mean, it's working fine. Let's open the terminal again. It's already there. Okay. So let's check the DNS things. So NS lookup is space data 01, data 01, yes, data 02, great. And then monitor 01, 02, 03 will look good, right? So on the client side, I put this DNS server IP under in this resolve file. So that is what my DNS server IP means, the IP address of my salt machine, and that one is the internet one, right? And currently I have this single interface with the single IP address, right? So for testing environment will not make any, but yeah, again in production environment you have to have at least two separate networks. So one for data domain, I mean the data machines basically where the data is actually getting stored, and the other network is for the monitor machine. So you need to have at least two networks, the private and public. So private will be connecting between the data 1, data 2, data 3, data 4, like that, and the public one will be connecting between monitor 01, 02, 03, 04, because monitor machines will be a public facing machine, right? So client will connect to the monitor first, then to the data. That can be the one reason. Second is the security concern, right? We don't want to allow someone to, the third reason can be because see, in between these data machines, a node, a lot of things happen between the data, because we are going to play with the data. Rebalancing, replication, eraser coding, everything is done through that particular network. So I don't want to enhance the overload of that network, because somewhere it is going to degrade the performance if you are using a single network, right? But for testing I'm going with this single interface. But for in the real-time environment, yes, you have to have a two separate network for many different reasons, for security reason, for performance reason, etc, etc. Okay. So DNS is good, SH is, yes, it's working fine, I can see. So yeah, it's good. With all 5 machines I did the same. For operating system, yes, you can use SLE 15. I am using a SLE 15 version SP1 basically. So SLE 15 SP1. Firewall, yes. So I have my firewall disabled in all the machines. So all the node. Firewall D, yes, it's good, disabled. And application armor, yeah, and I did this command. I put my these services down in all 6 machines. So that is a common status, has to be there in all 5 machines or 6 machines. Right. Every machine should have registered with the correct things. DNS must be configured so that they can communicate with the name. The passwordless, yes, it is from the master. I mean, from the salt to other 5 machines. Operating system is SLE 15. That's good. Firewall is disabled. Application is disabled. Application armor is disabled in all the node. And NTP is, yeah. Let's check the NTP also. So in SLE 15, basically we have a crony, right? So if you want to host or set up NTP locally, you go with the crony. Because I am having an internet connection, so I thought why not use the global NTP upstream server, right? So yes, I'm a part of that. So let's check that whether the time and date is correct or not. So data 01, data 02, data monitor 01. I'm going to run a loop beside running a date command in all the node. So it will run the date command first in my machine, then semicolon, and the other chain command. So I'm going to chain up a command together through this colon. So date and done. So all the node have a 23. That's cool. R12, 46. Yeah, there's some fluctuation in the second, but that's Kerberos allow it. So there is no issue. But it should not be a very much difference in minute, because Kerberos is going to check those things, right? And for authentication, of course, the time must be sync, because we have a certificate things here. In the later part of section will show you, and certificate is released for a certain period of time. But my time is not same, then there is an issue, right? So yeah, it look good. NTP is okay. Now it's the time to configure SUSE Enterprise Storage 6. So SUSE Enterprise Storage 6 is basically uses a deep C method. I mean deep C. Let me write it here. Deep C, SEE. So SUSE Enterprise Storage installation is basically automated using a deep C, which basically uses a salt to execute a command needed to deploy the necessary configuration. So in short, if I say deepc is basically going to call to the salt to execute the job to the target machines, means all those 5 machines. So salt is it's a requirement for it, right? So I'm going to configure a salt here. So on the master machine, meaning is on this machine, admin machine, I have to install my salt master and salt minion. Within all the other node, you have to install zipper space install space salt hyphen minion, right? And I done this part already. In interest of saving the time, I done this part already. I mean the installation part only, right? So minion and salt hyphen master, yeah, it is installed. Yeah, it is a time to configure my salt master. So to configure my salt master, you have to go to this file, only minion, right, and enable this section and write this. So on this machine, e go to this file, salt dot, and you have to write master colon salt dot example dot com. That is one, right? And second thing is you have to create a file id file, because salt is going to identify a machine on the basis of id, and the id is automatically generated. But sometime I face some issue, like the id which is there is not the correct one. Even id can be anything, but I want to fix something so that it will not change. So yeah, I did that already. That's cool. So on this machine, the same machine, go to this file. This file does not exist already before. Yeah, so minion one, minion underscore id. So you have to create this file and put the correct name here. So that is the one part of job. And on the other machine, you have to go to the monitor one and check this. Remember, I configured this file already, but when you come down into this file, the line will be comment. So you have to remove the comment and then enable it. And second is you have to create this file and put your correct name of machine which is there already. That's cool. And for monitor 2, go to this section, salt. Yeah, the name is correct. It's pointing where my master is, where my salt master is. So it is running here. That is a one. And second is your name of machine. So I believe I done this part already. Let's come back to my master machine now and check the status of my service, salt hyphen master and salt hyphen minion. So it is running. Okay, let's check the same for other machine. I believe I started this already. So salt minion only. So on the other node, it should be just the minion. That's cool, running. Now we have to see the keys which is already accepted. That's cool. But let's say because I done this part already. So on the other node, you have to go to this file basically and address your master machine. You have to write this manually, and then you have to go to the other file which is salt hyphen minion and underscore id and fix your name of machine. So in my case, it is monitor 01 02 03, and you have to do this job manually in all these 5 to 6 machines, right? and after it you have to start the service. Systemctl start and salt minion, and you have to enable it also. And same you have to do for master machine. So C systemctl start salt hyphen master and salt hyphen minion, right? And you have to enable it also. So once we start the service on the other node, on other 5 node, you can see some request here on the master machine, some fingerprints request. So you have to see this salt hyphen key hyphen f, and then you have to accept the key. Like you can see all my keys are accepted in my, yeah. So salt hyphen key uh, hyphen accept hyphen all, and I done this part already, so my keys are accepted, right? So okay, so that is the oh, control job is stop. So if I start in background, yes. If I put it in foreground, oh cool. So yes, start and minion, and one more, which was that is the one on the other machine. Okay, enable it also, right? So that is actually a salt configuration that you have to do. Right. Now moving next to it. So okay, so you have to install deep C as I said earlier. So system C zipper space install space. I believe it is installed because when you install this the first package, it gets installed as a default. Next is you have to install some grains into it. So let's check this first whether this salt is working fine or not. So test dot ping. So I can run, yeah, all cool. It's working fine. Now next is going to install grains semicolon, yeah, sorry, quote grains dot append space deepc space default. Yes, now it is a time to check that whether it is able to connect to the minion using these grains or not. So salt space, then test.ping. Yeah, it looked good. So as of now, it look working fine, right? So now moving to the next part of it. So I have to write this step here. This one, installing. Yeah, that is on the master machine only. On the salt machine, or you can say admin machine. Right, that is the first step. Second is you need to install these grains. So grains are, yeah. Third is to check this communication using these grains. All right. So as I said that the goal of deep C is to save the administrator time and confidently perform complex operation on the Ceph cluster. And Ceph is a very configurable software solution, It increase both the freedom and the responsibility of the system administrator. So now we are going to run some stages here. So basically DeepC collect each set of tasks into a single in a single file, and each goal is a stage, right? So here we have six different stages. So stage 0 is for preparation, where this stage basically all the require updates are going to apply to your system, and your system may be rebooted, not very sure, sometime it get rebooted. Yeah. For stage 1 is called discovery, where your hardware of your cluster is going to be detected, and the necessary information of the SAP configuration is being collected. Stage 2 is the configuration things, where your it's going to prepare your configuration data in a particular format. The third stage is for deployment. So there are stages. Let me write it here. So stage 0, which is for preparation. Stage 1 is for that is for discovery, to discover your hardware. Stage 2 is for configuration. It is going to prepare configuration data in a particular format. Stage 3 is for deployment the basic set cluster with the mandatory services. Stage 4 is for that is actually called services, where we install additional feature of SAP like iSCSI or object gateway, SAPFS, etc. And stage 5, it's a stage, not state, right? Stage, yes. Stage 5 is used for removal. If you want to remove, then in that case you can use it. So these are the stages. So it is a time to run the stages, right? So for that we need to run a command called deepc space stage run sap stage dot 0 and enter. So as I said, it is going to prepare your note, right? So that is for only for information section. That is that is our information section. So you have to run this command called the C space stage space run sub dot stage dot 0. So monitor nodes are more like a client facing things. So when the client want to connect to the actual data, the path, the process going all through the monitor node. So monitor perform authentication things. Monitor has information of the cluster, their state. It also contain the map of the cluster, right? So when the client want to connect to the Redis cluster, the process go all through the monitor node. But the next time, uh, uh, once the client receive the map, it can directly communicate to the cluster node under in a particular placement group. So, and this kind of placement is done through the CRUS algorithm, right? So CRUS is going to decide where the data will store, right? So yeah, it's running, and I would like to show you something here. Survey pillar, yeah, it's so you can run it. So currently we have 1, 2, 3, 4, 5, 6, 7 different objects. So that is not an issue. It is going to check whether these things are packages are installed or not. So it find no, it's not installed. So it is going to install now. Right. So let me pause for a while to save uh, the disk space. So we'll back once this is done. So yes, that part is done. So stage 1 is done. 0 basically. Now run for stage 1. So the stage 1 is going to discover the resources, the hardware. So let me pause it back. So yes, the stage 1 run correctly. So out of 3, all succeeded. So now next stage is stage 2. That is the most critical and important one. Of course, all the stages are important. Why I'm saying this here, you cannot run this stage 2 directly. Because see, as of now, we have yeah, discovery is done. So we have discovered your resource nodes and prepare the environment for the configuration stage, which require that I mean which require you to create a policy.cfg file that will map the element of these Ceph environment to the specific node. So before moving down to the stage 2, you have to create a policy file where you will map your node to the specific role, right? Because as of now, you have your machines are prepared, your resources are discovered, but your configuration data is not yet ready. So, and yeah, so okay. You can see one thing more here. Proposal folder is get created. It is a time to map your node against the row. That's interesting now. So let's go here, SRV pillar, and you can see that folder is just generated, right? And inside here you can find a list of different roles, right? SAP cluster, you have SAP monitor, manager, metadata server basically. Role is master. These are the access method, IG gateway or Redos gateway, right? So it is a time to map your node against the role, the element of your Ceph cluster. So for that you have a one default file here, USR share doc packages deep C DEE example. Here you can find one file role. You have to copy this into SRV pillar test then yes Ceph, yeah, right here you have to copy it. So I'm going to copy this default configured file to this location, and then we have a so yeah, right here. So copy this file here. Yes, okay. So SRV went into here. So I'm going inside this folder. Yes, rename this file. That has to be policy.cfg. Yeah, and configure it. Right. So here you can see the name of roles are given: admin, monitoring, etc. So I want this role to be assigned to my salt machine, salt node. And admin also has to be. Monitoring, yes, has to be attached to or mapped to salt machine only. And Grafana, yeah, these are the monitoring tools. So Grafana is to generate a graph where Prometheus is used to for monitoring purpose basically. So for monitor roles has to be in all three monitor nodes. So that's why mon star. So mon 1, 2, 3. For manager also it has to be on all three manager monitor node. For a metadata server has to be on 3. So when we see these things like architecture and all, we will get to know that what is the meaning of this MDS. MDS is basically a metadata server used by SAP FS, CEPHFS file system, right? And MDS server is only used by SAP FS file system. So there are many different method to access the Redis cluster. libRedis is there. You have this SAP FS is there. You have Redis gateway, right? This one, right? You have IGW. So there are many 4 to 5 different method to access your Redis cluster, right? So that MDS is basically used only by SAFFS. So it maintain or hold the metadata required by SAFFS file system, right? Okay, so IG gateway has to be this access role has to be, or access method has to be on the monitor node only. Monitor, yeah, it's an NFS utility to access your storage in form of file, right? File system. So monitor file storage basically. Yeah, in the last you can decide the number of node which will actually store your data, the real data. So currently I have data 10102. I can mention it, right? And the question is, can we add a monitoring node into the storage? The answer is yes, but it is not recommended. Because monitor node has some different roles. They have some different responsibility, right? It is more like public interface node that do a lot of job first to allow a client to access the Redis. So it will not make any sense to put all those two different personality into the same box, right? But yes, you can do. Let's do with it. So star 1-3, then yeah, that means it is going to call all 5 node, meaning uh, monitor 01, 02, 03, data 01, 02. So all these 5 node will be acting as a storage node for me, so I can store my data to all this. Anyways, my file is ready. So that is what I was saying, you have to create this file to mention the role of the node, or you can say to map the role against the node, right? So yeah, okay, save it. Now you have to run the stage 2. Enter. So yeah, so we are very close to finish this process. I mean, finish this deployment. There are 2 more stages has to be done. Okay, so let's pause back. So I can see that all 15 stages or states are run correctly. So that is now my yeah, that is now my third stage 3, which is going to execute the deployment. So the stage 2 is going to collect the configuration data, stage 3 is going to execute them. Copy, paste. So almost I have faced a 30 plus different error while deploying this you know storage 6 from the scratch, because sometime my salt was not correctly configured, sometime discovery id was not correct, sometime I did not created sub volume, right? So there are a lot of steps that you have to run in a same order. And the thing is that let's say in a stage 3 there are some issue just because of you did something wrong in the policy file. So the method is here, the order is you have to rerun the stage 2 and then stage 3. Getting? So whenever there is a change in the policy file, you are supposed to re-execute the stage 2 and stage 3 back, because the stage 2 is going to recollect the configuration data, right? So if you make any change in the policy, the stage 2, then stage 3, right? So yeah, DNS has to be correct, yeah, because I'm using a single IP address here, right? Public IP. So and then later I configure my DNS on my salt machine. So the problem was my client machine, because meanwhile the process is going on, my client machine, client meaning is monitor one, let's say, for example, it's not really client, but yeah, all other minion basically, right? So you can see every time my this agent machine getting this internet IP, right? And internet DNS server basically, right? It is coming all through from the outside, and I wanted to mention this one because I have my DNS running here. The problem is whenever I add this line here now, it get overwritten by this IP address, because that is managed by all through the external DNS. So for that, what you are supposed to do, you can read this line here. You have to go to this file, right? You have to search these two lines, DNS static searchable list and static IP. Then what I did, I went in this location, and then I put my you can say if I go little down, page number sorry, line number 182, I remember because I did a lot of troubleshooting here. So 182, yeah, right here. So you can see, right, I put my DNS name explicitly here, and I mention my DNS server. If I don't do that now, then you will get a public internet DNS every time. Will have a problem then, because you have your own DNS here. And if you don't use DNS, then there is another issue. Right, earlier I was using a host file. So the problem is, so when I discover the node through the salt, it does not fetch the host name. So ultimately I need a host name, right? And that can be done through only the DNS only. So when I come to the DNS, I face a different problem. The problem is it's not going to update the resolve file. Resolve file is getting update automatically. So I put this two line here, and then I run this command, netconfig update f, so that your configuration will fix, right? It will always give priority or preference to your local DNS first, then to the outside DNS. Just because I'm having a single interface, so that was the issue. So these are the some small issues I faced throughout this deployment. but ultimately, yeah, as of now, I'm in the correct stage to deploy it, right? And one more problem I face when I was deploying this. Let me recall it. The issue was a survey. No, not in monitor machine. Go to this machine. Yeah, correct. So yeah, next is cluster. Oh, CD set. Yeah, go to proposal. These are the small mistake I did first. So in the first time, actually, I forgot to mention my salt master name here. Where? Inside this location. Salt. I forgot that. So the problem is, if I forgot this, the file does not get created. This one, it is not going to discover your machine, right? So when I run the stage 3, it is not going to find my master node, and the result is fail. So I was stuck there. I spent some time, checked it out why this is happening. So in the later time, after that, I found it that I missed that line, this one here. Even you can create this file manually. There's no issue, but you have to rerun the stage 2 and 3 again, right? So you have to be very particular regarding this. You can see here in, yeah, I have a cluster inside. I have these SLS files, right? So that was one of the issue. If you have any file missing, your stage 3 will not work, because you have mentioned this inside the policy CFG file. You can see if you go down, pillar and then proposal, not here, yeah, right here, yeah, policy. You have mentioned that which node will work for which responsibility. So yeah, for master, you clearly mentioned that this has to be for the salt sleeve files. If the file is missing, the role will the job will not work, right? And why this file can be missing? If you have some wrong configuration in the salt, right? Okay, so let's pause it to save the time. Save the space. Yes, all correct. All 65 uh, jobs run correctly. Now moving to the last part of this exercise, which is the stage 4, which is going to deploy additional services. So these are basically the access method to retrieve or store the data into the Redis cluster. So that's the final stage. It will almost take, I believe, 20 minutes or something to complete the whole process. So let me pause this back. So yes, all these steps are run successfully. So it is a time to log on into the chef dashboard. So OpenATIC is basically replaced now by chef storage. So let's check. Go to the browser. https://monitor01.example.com 48443. Accept this using a self-signed certificate. So, oh, I think I checked something wrong. Okay, so go to accept the, yeah. You need by default username is admin, And to fetch the password, I need to write salt space -I. Then yeah, pick this from train. So here we go. Just hit paste it, login. So yes, it look good. So we have a 3 monitor, and we have a total 10 OSDs. Yeah, that is what I mentioned to. All this node have I have added 2 hard disks with each node. So each hard disk is known as one OSD. So 1 and 2. So in total we have a 3 disk. One is for OS and rest 2 for OSD. So in one node we have a 2 SD, and total node we are using for storage are 5. 1, 2, 3, 4, 5. So that's why we have a 10 OSDs, right? And manager daemon is one is on standby, and one is on active, and 2 others are on standby. So manager daemon always run with the monitor node. So monitor plus manager run together. Gateway 3, because I use those node 01, sorry, monitor 01, 02, 03. That's why we have a metadata server running on 1, 2 are on standby. Total iSCSI running on all 3 monitor nodes, so I can access. Yeah. So yeah, that's all. Look good. So that's all about deploying SUSE Enterprise Storage 6. And we'll come up with some new videos going into more detail how these access method work in my upcoming videos. So let me write this here, not this one, there, history. Okay, yeah, right here. Yeah, copy. So yes, so you can write here for Firefox https://01 example.com:8443. That's all. Yeah. Okay. All good. So have a good day. Thank you.